Hello, here we are again. Let's keep solving problems in 2D trusses. And let's check this problem out. This problem says that if you don't want any member of the truss to be subject to an axial load, tension, or compression greater than 20 kilonewton, what is the largest acceptable magnitude of the downward force F? This is a problem that we don't know the value of the load, and that's what we want to calculate, but we know the strength, the maximum force that every element can withstand. Usually what most of the people want to do when they see this type of problem is putting 20 in each one of those trusses and calculating that. And that's not the way of going, because none of the values are going to, or not all of the values are going to be 20. Values are going to change according to the inclination, geometry of the element, length, etc., etc., etc. So basically what we have to do here, what we're planning on doing, is calculate all members in function or as function of our force F, and then select the appropriate value for F. That's what we have to do. And the problem is not complicated at all. But once you start looking at this problem, you really don't know how to start. Yes, I know I can solve the joints. This is a roller, this is a pin, meaning I'm going to have this and this, Bx and By. And this is a roller, I'm going to have only one force here, which is Dx. And I can calculate those reactions also in terms of F. But that's not going to help me out too much. By the way, at this moment you should be also realizing that this is a zero force member. But we're going to show it later. If you look at this joint. If you look at this joint and you do summation of forces in Y, this has to be 0. Anyway, we have to start with this one, right? So we have the joint A. Let me put the joint A here. And I have my force F, which I know is unknown, but for our analysis is going to be a constant. I have this force here, and I have this force here. This is my force AB, and this is my force AC. And you know something? I need the angles. For example, this angle and this angle. Because this angle is going to help me decompose this one, and this angle here is going to help me decompose this one. And how do I get those angles over there? How do I get this angle? I don't know. Okay, let's start with what we can calculate. I can calculate this angle. Yes, I can. Is that going to help me out with something? Yes, of course it's going to help me out with something. Can I calculate this angle? Well, for calculating this angle here, I'm going to call this angle, I don't know, alpha. For calculating this angle here, I'm going to need 2 dimensions and I only have one, which is this. I'm going to need this or this, but can I get this dimension? Oh yes, I can, because I have this 3 and this is 4. So then if I go to that triangle, that first triangle here, if this is 3 and this is 4, this value here is going to be the square root of 4 squared plus 3 squared, which is 5. That means that distance here is 5. If that distance is 5 and this is 12, then this angle here, alpha, is going to be equal to the inverse tangent of 5 divided by 12. And that is 60. This angle here, inverse tangent of 5 divided by 12. I then calculate that angle. Let me see. That angle is going to be 22.62. Yes, that angle here is 22.62. And what for do I need that angle? Well, I don't need that angle per se, but I need all the other angles. Let me see now. What else can we do here? I can calculate this angle here. Yes, I can. Do I need that angle for anything? Well, let's think. This angle here, that angle is going to be inverse tangent of 4 divided by 3. That means that that angle is going to be 53.13 degrees. Now I have that angle, 53.13. And this angle is also known because I know alpha. I know alpha, which is this, and this is 90 degrees. That means that this value here has to be 90 minus alpha, which is 67.38. And now if I have this angle and this angle, I can also calculate this angle, which is basically this angle. And that angle is going to be 180. That angle there is going to be 180 minus 67.38 minus 53.13. And that value then is 59.5 degrees. So now I have this angle, 59.5 degrees. If I want to calculate this angle here, this angle I know it. Now, the other angle that I needed was this. Well, that angle would be this angle here. I know this because I calculated. It's this, 22.62. Do I know this? Well, now I know it because I know this angle here. I just calculated that angle, which is this one. Meaning this angle here is going to be the complementary with this one, 30.5. And if this is 90 degrees, and I say 90 minus alpha, and alpha is 22.62 minus 30.5, it's going to give me this angle, which is 36.9 degrees. Phew. And that's only calculating the angles, so I can start working. But now the problem is exactly or very similar to all the problems that we have done before. So now this angle here is 36.9, this angle here is 59, and this angle here, if I wanted to, is 30 point something, 30.5. There you go. Now is when we can start working, and we say summation of forces in X equals 0. And then if we do that, we have negative AB cosine of 36.9 minus also AC. Either I say sine of 30.5 or cosine of 59.5. I'm going to use this one. Sine of 30.5, nothing else going in X, equals 0. Then this is going to be my equation number 1. And if I do summation of forces in Y equals 0, in this direction, then I get negative AB sine 36.9, because it's this one that I'm looking for. Same with this one, negative AC, now cosine 30.5 minus F equals 0. And this is my equation number 2. And you have to solve this system. Once again, you are stuck with that system because you have to think that not everything can be done, or well, sometimes yes, but you have to use the tools that you have. If your calculator doesn't solve for literal equations with letters, then you have to come out with a little bit more of ingenious solutions. So what we're gonna do basically is this. I have my two equations. My equation number one, it was AB. I'm gonna get this equation, and I'm gonna solve for AB sine 36.9. So if I do that, I will have, I'm gonna put it here. I'm gonna have AB sine 36.9 is gonna be equal to negative AC cosine 30.5 negative F. And from here I'm gonna solve for AB cosine 36.9. So AB cosine 36.9 is gonna be equal to negative AC sine 30.5. And then, as you can see, if I divide term by term or side by side, this and this cancel out, and then I have tangent of 36.9 equal this and this cancel out, so this is going to be cotangent of 30.5, and this cancel out the sine, plus F divided by FAC, or AC I call it, AC, this one, sine 30.5. Now my only unknown here is AC, and it's going to be expressed in terms of F. I pass this to one side, and then I get to FAC is equal to negative 2.08 F. And if I plug this back into here, for example, then I can get my AB being equal to 1.32 F. Once again, I know this means tension because I assumed originally in tension my force AB, and it was positive. But if you look at AC, AC is this one. I was assuming it before leaving the joint, and actually it's entering in the joint, which means this force here, if this is the joint A and this is AC, this force is going to be in compression, the force AC. Now we move to a different joint. This is this joint. I can move either to this one or I can move to this one. If I move to this one, how many unknowns do I have? I have 1, 2, 3, 4 unknowns, so that means that I can't go there. If I go to this one, I have 1, 2, 3 bars, but this bar I already calculated, so I have only 2 unknowns in that equation, and in that system equilibrium, and that's where I'm gonna go. I'm gonna go to the joint C, which is this one, and this here is my force AC. AC was just calculated, and as you can see here, AC has to be entering in the joint here. Yeah, here in this direction, entering in the joint. I'm gonna redo this part here. So my force, my joint C, which is this. Let me put it here. My joint C, which is that joint, is gonna have this force, and this force. This force is AC. I just calculated AC entering in the joint, and the value for AC was 2.08 F. And listen, look at this. I'm not putting the negative sign because I already changed the direction of the force. So that's important to remember. What else? if you want to study these two forces, you can see that this force has to go up because this is the only one going down. This is the only one that can contrarrest that. And if both of them goes to the left, this has to go to the right. The name for this force is BC. And the name for this force is DC. And I know this angle because I previously calculated. And this angle, when I calculated before, it was here, 53.13. Now we proceed and we do summation of forces first in Y because I have only one unknown in Y. And then it's going to be BC sine of the angle minus 2.08, and I already calculated this angle also here, remember, which is this angle here. We calculated at 30.5 degrees, or we can use also this one if you want to, but I'm going to use this one. So it's going to be cosine of 30.5 equals 0. If I use this one, this is going to be 59.5, and then it's going to be sine, not cosine. And then I can solve here for BC, and BC is 2.24F, and it's positive. And if I do now summation of forces in x equals 0, then we get that DC minus the horizontal component of BC, 53.13, this is the sine. This is the cosine of 53.13 multiplied by the force BC. Negative because it's going to the left. And this is also to the left, so it's going to be negative 2.08F, this time sine of 30.5 equals 0. You know BC because we calculated before. You put everything together and then you get DC equal 2.4F. So the only piece of the puzzle that we are missing is the force BD is the only one that we are missing, this force here. And for that, I can go and analyze the joint D. And then I have DC. I have this reaction, which is dx. And I have my force BD. DC I calculated before here, and DC was entering into the joint, meaning DC is going to be entering into the joint, and the value, I don't have to put it because I don't need it, but it's going to be 2.4F, and this reaction obviously has to be equal to this, so I know the reaction is going to be 2.4F, I don't need it, and BD is this one. Remember I told you at the beginning that this is a zero force member? Well, now you can see it, because if you do summation of forces in Y equals 0, then BD is going to be equal to 0. Now we have all our forces. We create our table with our results. AC, AB, BC, DC, BC. BC no, BD. BD is the last one that we calculated here. I have it here. It's 0. So this is going to be the force, the value, and if it's tension or compression. Then we have DC 2.4 F tension, BC 2.24 F tension, AC 2.08 F compression, AB 1.32 F tension. Why tension compression? Because sometimes you can have materials that they behave differently to tension and compression. So you really need to know to include this in case, for example, if this problem tells you that the maximum internal force is 20 kilonewton in tension and 10 in compression, or vice versa, then you have to compare the 20 with all the forces in tension and the 10 with all the forces in compression and get the minimum of the forces. That will be the procedure if you have different behavior to tension and compression. But in this case, I know that the maximum value that these forces, or the force here, can take is going to be that value that doesn't make any of these greater than 20 kilonewton. The biggest one here is going to be this one. So I'm going to say that 2.08 F has to be equal to 20 kilonewton. And my F is going to be equal, I mean, not this one, because this one is the smaller one, not the smaller one. The biggest one is this one. So I have to take the biggest of the forces, which is this one. So I have to take, now, which one of these forces are the forces that, which one? Okay. Now the problem is that we have all this table and we have to figure it out which one of those forces or which one of those internal forces are the ones that are going to be smaller than 20. Remember, all of them has to be smaller than 20. Not only one of them, all of them. But the one that is the biggest here, 2.4 F, is the one that I'm worried about, the biggest one. Because if the biggest one is smaller than 20, the rest of them are going to be smaller than 20. So F is going to be 20 divided by 2.4, and my F has to be smaller or equal to 8.33 kilonewton. That's the way you solve this problem. What happens if I use this one? Let's say this one. If I use this one, then I'm going to have 1.32 F equal 20, and when I pass the 1.32 divided by 20, that's going to be a value that is going to be 20 divided by 1.32 is going to be like 15 or so, almost 15. And when I go back, if I put 15 here as F, this force is going to be more than 30, and it's more than 20, which is the maximum that I have. So that's why when they ask you for the minimum force, the minimum weight, that means the maximum weight that this can take, that maximum weight usually is the minimum in these ratios here. So you have to use the maximum coefficient for the maximum forces. Well, I hope you like this problem. We did something like that before, but not applied to trusses. Now we apply it to trusses. This is all that I have for you for this moment. I'm going to keep solving these type of problems. Probably I'm going to do 3D now. And then I'm going to go to the method of the sections and zero force members also. Have a good day.